Dear students, let us continue our discussion on the alignment design as a part of module 3. In the previous interaction, we discussed about the various types of surveys which can be utilized for fixing an alignment, and in that we talked about 4 steps, and the culmination of those 4 steps was a preparation of a detailed project report, and that project report or the DPR, which is being termed in short, consists of lot many information, not only in the text form, but also in the form of various designs and plans and drawings, which are further utilized in the field for the construction of the road or its components along the alignment. Now, once we have talked about that, now let us move inside and discuss about the various types of features of alignments which can be there. Again, I will take you back to my first interaction on this particular topic or a module, where we did discuss that the alignment may have the horizontal features or the vertical features, and that is where they are defined as horizontal alignment or vertical alignment. And then within a horizontal alignment and vertical alignment, again there are different elements which needs to be designed and which needs to be provided, so that the movement which are there on road or that particular alignment which is being developed in terms of a cross section of a road remains safe, efficient, smooth, comfortable, etc., etc. Now, when you talk about this horizontal alignment, and if you look at the diagrams which have been shown on the right hand side, what you found is that there is a tangent which is also being defined as a straight section. There is a circular curve because there is a requirement of a change of direction. So, we are going say in this direction. So, we have to take a turn like this and then go in this form. So, again there is a change in direction. So, in the first case, when we have a straight and the circular curve, they have been connected by way of a provision of a transition curve in between. But if we talk about the another one, then the tangent is directly being connected to the circular curve. There is no transition curve being provided here, and these are the possibilities which are there. So, it means we need to talk about a circular curve, we need to talk about a tangent, we need to talk about a transition curve. As far as the tangent or a straight is being concerned, we have discussed about it under the cross section elements, because that defines that what are the things which are going to be there, accordingly what is the width of the section which is also going to be there. In continuation of these or in association with all of these things, the other future things which are going to be there are like super elevation and extra widening. These are the two things which are associated here, and we are going to talk about all of these things one by one. But before we go into the details of all of these type of things in terms of an horizontal alignment, let us first of all look at the circular curve and what are the requirements, what are the things which need to be taken care of when you are providing a circular curve. So, let us have some general guidelines here. The very first thing which says is that we should have an alignment which is quite fluent. That means it is very easy in the sense that if you draw it, you just draw it say by a free hand. So, it is sort of a fluency is there, the flow can be there very easily along that, and at the same time it fits well with the surrounding topography. Whatever the type of terrain, whatever the type of things which are there in that particular area, it should fit well with those things. So, if there is a building here and there is also a building here, so it is passing through it, or there is some deviation is required because of some other thing, all of those things when it fits well and takes care of the requirements of that particular area. Another thing is that the curve which we are designing, it should have the largest possible radius. So, when we say it should have the largest possible radius, that means what? Why we are trying to provide this largest possible radius? Say if we talking about this, one way is that I am providing a curve like this, another is I am going to provide a curve in this manner. So, there is R1, there is R2, and obviously R1 is much less than R2. Now, when we are looking at this largest possible radius, The reason being that if we are talking about this, then there is going to be the centrifugal force which acts, and this centrifugal force is inversely proportional to the radius of the curve. So, if this is high, then this force magnitude is going to be lower, and therefore, the tendency of the vehicles to go out of the system will reduce a lot. But when we are doing this, then we are trying to take into consideration the ruling design speed. Now, I am going to take you back to the design speed factor which we considered initially. And this factor we discussed for both urban roads and the rural highways, expressways, 2-lane, 4-lane, 6-lane highways, etc. And there these design speeds were defined for different terrain, for different category of roads. So, you have to keep it in mind, that aspect. And there the ruling design speed, not the absolute minimum design speed we are talking, needs to be taken care of, which will result in the ruling radius. So, this is another aspect to be taken. Then the sharp curves, they should not be provided at the end of a long tangent. When we say long tangent, as I already said, that we are talking about basically a straight section. So, you have a road which is going like this, quite straight in nature, and all of a sudden you provide a curve, and which is quite sharp. Now, what it is going to create a problem is that all of those vehicles which are moving here, all of these drivers, because of this track or this alignment which is continuous and straight, they are going to lose the alertness. So, there is a reduction in this alertness, and because of that now they are more casual in their approach while driving, but all of a sudden if this type of a sharp curve comes, then it may result in a hazardous or dangerous situation, and we have to take care of that. So, this should not happen, and that is where it also says that what should be the length of this particular straight stretch, which is going to create a monotony in driving. So, that is another thing we have to take care of. Now, curves which are being provided, they should be sufficiently long with transition curves. The reason being that if we are providing say a tangent like this and a circular curve is being provided in this form. So, there is going to be a sort of a jerk or a kink at this point. Okay, so, this is a circular curve, and there is a tangent on this side and a tangent on this side. But say if we are talking about another case where the circular curve is there, but then this circular curve is being connected by way of a transition, then it is going to have a better or a pleasing appearance, because the radius of this curve is being achieved from infinite to a value r along this particular section. So, that is another aspect we need to take care of. As far as possible, the reverse curves shall be avoided. Okay, so, the curves which are going like this, if we can avoid these type of curves, because again the steering conditions or the change of the radius, all of these things are there, but if they are really required, then in those cases again it gives an idea that how the points at which these curves are being connected should be designed, and those points may be in terms of the tangents which are sufficiently long and allow to give to the driver the time to understand and change. Then broken back curves. Now, what is broken back curves is basically we are talking about a compound curve, but in this compound curve they are not something like that we say that there is a curve which is like this, and then there is a curve which is in this form. So, there are the radius is in this way, the big one and r1. So, this is r1 and this is r2, and instead of this what we are saying is that there is a curve and then there is a small tangent and then another curve. So, this is a straight section. So, what you found is r1 here, r2 here and a straight section here. But if this straight section is a short tangent, then they are being defined as a broken back curves, and this should be as far as possible avoided. And when we say avoided, what we try to do is that this thing should be transformed into a one single curve if possible. If this can be done, then that is a better alignment. Then horizontal alignment needs to be coordinate with the longitudinal profiles, whatever longitudinal profiles are being defined. In the case of elitarian, the one typical condition can be is a hairpin bands as being shown in this photograph. And as far as possible, if these hairpin bands can be avoided is one thing. If they are not in a position to avoid, then we have to see that whatever is this is happening, we should try to have the straight section in between the two hairpin bands, so that again the driver who has negotiated one band has a sufficient time to regain par with the vehicle and then negotiate another one. In some of the cases, if it is possible, if we can eliminate, say for an example, suppose if there is a possibility of eliminating it and this becomes a case here, so then this particular section is being eliminated, but this all depends upon the terrain conditions. Then a curvilinear alignment with long curves is better on rural highways from the point of safety and aesthetics, and the reason is the same, that we are trying to look at the forces which are there, which are going to act on a vehicle which when it negotiates a particular curve. So, that is where this alignment which we are talking, we have to ensure the safety, and centrifugal force is one thing which will try to take the vehicle out. So, there is possibility of skidding or overtakings in those scenarios. This control of R is going to help us. Then long tangent sections exceeding 3 kilometers in length should be avoided. The reason being the same, we talked about it in the previous discussion, where we said that if it is a total continuous stretch, then it means you simply lock the steering and go to sleep as a driver, and your vehicle will keep going ahead. But if you are looking at that particular aspect, if any other thing happens on the road, or any other road users has an issue, or something new element comes on the carriageway and you are not alert, and it has resulted in a monotonous drive and your alertness has reduced a lot, then there is going to be a dangerous situation, and we need to omit this dangerous situation. And that is the reason it says that the long tangent sections exceeding 3 kilometers in length should be avoided. That means every 3 kilometers or so, if we are going to provide some deviation, then that particular deviation is going to help in the improvement in the alertness of the driver. So, that is what we are trying to say. So, this should not be greater than 3 kilometers here, or should not be greater than 3 kilometers here. So, something like that is a thing which we are talking here. Now, short curves, they give appearance of the kings, especially for small deviation angles, and should be avoided. Now, when you are looking at this, it may happen that in a plan, if we talk, there may be a possibility of like this. So, what you found is there are many curves which are coming at this one, these short curves, this one, they are short curves, this is okay. So, can we just remove these short curves and can create a one single curve like this? That is what we are trying to see. So, those short curves which are creating an impact, visual aesthetics are being just devoid, we need to take care of that also. Then the reverse curves may be required in difficult terrain. As you can see, this is a difficult terrain and there is a continuous movement like this, this and this. So, these are the reverse curves which are there, but obviously in this particular type of condition the speeds are going to be controlled a lot, because again you are having a left, the right, and the left and the right movements. So, as far as possible we should try to avoid them, but there is also a condition that we cannot avoid, and therefore we have to provide them. Now, when we are doing these things, then is it possible that we can have a curve like this, wherein there is some straight section which comes between the two such reverse curves? And if this can be done, then this is also going to improve upon the safety, it is also going to improve upon the maneuverability of the vehicle by a driver, and it will also be reducing the fatigue of the driver while driving in this particular terrain. So, as far as possible, the sufficiently long distances, these should be made available between the two curves for the provision of transitions. So, this is true in all the cases where you are talking about the continuations of the various numbers of circular curves, or you are talking about the reverse curves, you are talking about the compound curves, whatever are the conditions are there, we need to have some sufficiently long distance between those where the transitions can be fit in, or even if the transitions are not being fit in, they should result in a long tangent line. Now, compound curve with two curves in the same direction should be replaced by a long single curve as far as possible. That is what I talked previously also. But in few of the cases we may found that it is not possible. So, if it is not possible, then what needs to be done? So, what it says is that if it is not possible, then a tangent length equivalent to 10-second travel time should at least be ensured between the two curves. So, we have a curve like this, and then this curve is changing in this form. So, I have a curve in this one, and then the radius of the other one is say big one. So, these type of the things are happening and we are not in a position to make it only r, then what it says is that this is related to r1, and then let us have a straight section which is tangent, and then from here we can have another curve with r2, and this length which we are talking here, this should be equivalent to the distance which is being travelled in 10 seconds. So, it is 10 seconds multiplied by v. So, that is how we are going to get this value. So, this is another important aspect we have to take care of. In the same case of the compound curves, the another aspect is related with the ratio of r1 and r2, or what we can say is that the r2 is a bigger one and r1 is a smaller one. So, if I go with the another case, so it can say that if I am talking about r2 is to r1, then it is 1.5 is to 1. So, whatever is the sharper curve is there, then the curve which is a flatter one should not be more than 1.5 times, or 50% extra is what we are talking there. That is the limiting value which should be there between the two. And obviously, if it is getting less than this, then they are coming closer, it is 1.4, 1.3, 1.2, 1.1 and 1. As soon as it is 1, the problem is solved and we have a single one circular curve at that point. But if it is going beyond that, if it is more than this one, then it is always better that we stick to this types of solutions and we stagger them and have a straight section between those. Now, let us come to the another aspect is that when you talk about these tangents, when you say that I am going to provide the tangents like this and I have a circular curve in between and this one. So, I have a tangent here and I have a tangent here, and this is my circular curve. Now, these tangents, they are going to be defined by the direction in which they are moving, and these directions can be defined by two ways. One is azimuth, another one is bearing. Azimuth means we are talking at a rate of 0 to 360 degrees, but when we are talking about the bearing, then you are talking about the quadrant system. So, you have 1 to 4 quadrants which are there, and depending on that, then the values are going to be defined. So, you have north, south, east, west. Now, if this is a tangent line, say my tangent is going this way. So, if suppose this one is just like this. So, what you found is that it is at a 30-degree angle from the north. So, azimuth is 30 degree, and in terms of bearing it is north 30 degree east. So, from north you go 30 degree towards east, you get it. Similarly, if you are talking about say this one, so this is 30 degree out of 180, so 210 degrees, but it is in the this particular quadrant. So, it is south west, so it is south 30 degree west. So, this is how we are going to define these tangents. So, when we define these tangents, our objective is to get on the basis of this deflection angle, and this deflection angle, say defined by delta, is going to be a difference of these values. Okay. So, that is how we are going to look at it. Now, let us look at a simpler case of a circular curve. Now, here in this simpler case, as I have drawn previously there, I have a tangent or a straight here, and I have a tangent or a straight on this side, and this is my circular curve in the center. That is where when I say this point is being defined as from tangent to curve. So, it is T c, whereas this is from curve to tangent. So, it is, and that is when we are talking about say a movement in this direction. Now, if this tangent are being taken both one, then this is the point of intersection, which results in a deflection angle here as delta. From the point T c to C t, then I have a arc which is defined as the length of the curve, and then if we connect the point T c and C t straight, then this is being defined as a chord. So, length and chords are also there. Another thing is that the point from where the curve has started and the point of intersection of the two tangents, this is defined as the tangent length. And from this point of intersection, whatever is the point is there just below that on the circular curve, that is being defined as offset. So, this is required when you are going to trace the curve in the field using an offset method. So, those offsets are going to be there at different distances when you are going in this direction as x1, x2, x3. And then another thing is the distance between the chord and the arc of the this particular curve, and that is defined as m, and this is horizontal. So, these are the elements of a circular curve which we need to work with. So, let us look at these. So, say this is O, this is P, this is Q, say this one is being defined as T, no not T, we can take it something else, say P, Q, R, S, say S, we can make it S here, and this is say U, okay, and this is say Z. So, let us look at and find out the lengths. So, length of the curve. So, when you go with angle, angle is arc divided by radius, say the radius is r. The arc length is from P to Q. So, we are talking about PQ arc divided by this, and that is going to be the angle, and that angle is delta. So, therefore, the length of the curve is nothing but r into delta radians. Then tangent length. So, for tangent length, let us look at a triangle OPZ, and this triangle OPZ, this is 90 degrees. So, considering this PZ as your the POP as a base and the PZ as a vertical on that. So, what you found is that the tangent length, this T is nothing but this is T divided by R is 10 delta by 2. By the condition of symmetry, this angle is going to be delta by 2. So, what tangent length is comes out to be R into 10 delta by 2. And offset is E from the point of intersection or the point Z to this one. So, if we are considering this one, then this is what we have to calculate OZ. So, this is OZ minus R, and OZ is if we are talking, this is cos delta by 2 is equals to R. So, this is R divided by cos delta by 2 minus R is an offset. When you are looking at Vorsine is the distance between the arc and the chord. So, arc is related with the, if you, so you talk about say this is OU minus OS. So, OU is nothing but R, and OS which we are talking here. Now, we can discuss about the another triangle. So, we have OP and S, and considering that, then what we get is that this becomes 90 degrees. So, it is R cos delta by 2, OS is, so R minus R cos delta by 2 is going to be the Vorsine, and the chord is nothing but chord is 2 times of the distance 2PS. So, this 2PS is there. So, we have to calculate PS, and this PS again by using this triangle, this is R sin delta by 2 and 2 R sin delta by 2, we get this value. Let us look at this example, and here we have a circular curve which is being placed between the tangents. Azimuths are being defined as at the start of the curve is 265, at the end of the curve is 95. So, if this is a case, so 95 means this one and 265 is this one. So, if I just go ahead, so what is this angle? This angle is 5 and 5. So, total is 10. So, we have delta is equals to 10 degrees, and between that these we are going to have a curve in this form. So, now we have to calculate the various elements where the r is being given as 300 meters. So, length of the curve is r into delta if delta is in radians, or otherwise it has to be converted into it by using this. So, what we get is 52.35 meters. If we go for a chord, then it is 2 r sin delta by 2, and again if we place the values here, what we get is 52.29, and in the case of tangent length it is r tan delta by 2, again we get the values as 26.24. Then var sin m is r minus r cos delta by 2, so 1.14 meter, and offset is also coming as 1.14 meter, but it is not really a case that every time you are going to get all of those values quite similar, they may be different also. So, there is another example here. In this example, what is being defined is that all these angles they have been given in the bearing form. So, you have S 70 west and S 70 east. So, this is a case. So, this is S 70 west means like this. So, this is 70, and S 7 this is for east and this is for west. So, this is 70. So, if I extend it like this, that means I have these two angles as 20 and 20. So, my total angle becomes 40 degrees. So, delta is 40 degrees, r is being given as 200 meters. So, again we are doing the same calculations using the same formula, and what we get is the length of the curve as 139.63 meters, the chord length as 136.8 meters, tangent length as 72.79 meters, var sin as 12.06 meters, and offset as 12.83 meters. So, this is how in the case of a circular curve we can find out the values of different elements. So, we can stop here and we may be continuing with the other elements and other type of features related to the circular curves in our next discussion. Until then, thank you and goodbye.